let u equal the vector 2 comma negative 3 and v equal the vector negative 1 comma 6. We would like to compute u plus v, u minus v, v minus u, and 3u plus 5v. So if we have two vectors u and v, both emanating from, say, the origin, let's say that one's u and this one is v, then geometrically the sum is formed by the parallelogram law. We make a parallelogram, and the diagonal here is u plus v. Another way to obtain this is to take the vector u, and then at the final point of the vector u, draw the vector v. And then this vector is u plus v. Essentially, in this picture, the vector v is right there, the opposite side of the parallelogram. And then if you have two vectors u and v, then the vector u minus v is this vector from v to u. This is u minus v. And let's make sense out of that. If we were to take v and add to it the vector u minus v, then we would expect that the v and the negative v would cancel and we would get u. And that's what's happening here. In this second approach, we're starting with v and we're adding u minus v, and we get the vector u. Okay, so that's the geometry of it. But now we would like to do the actual computations based on the components of u and v. And that's pretty simple. To add two vectors, you just add the corresponding components. So u plus v, these are vectors in R2, so the result will be a vector in R2. The first component will be the sum of the first component, so 2 plus negative 1. And I'll write that for emphasis. And negative 3 plus 6 for the second component. And so the sum is 1 comma 3. So that's u plus v. U minus v is numerically computed in the same way. We just subtract. So it's going to be the two components again. It's a vector in R2. The first component will be the difference. The first component of u minus the first component of u. 2 minus negative 1. And negative 3 minus 6 for the second component. And that boils down to 3 comma negative 9. So that's the difference. V minus u, without even doing these complications, v minus u is going to be the negative of u minus v. And so that's going to be negative 3 comma 9. And to compute 3u, the last one, plus 5v, first we have to compute 3u. So you take 3 times the vector 2 comma negative 3 by multiplying each component by the scalar 3. So that's going to give us 6 and negative 9. 6 comma negative 9, that's 3u. And 5v, we'll take the scalar 5 and multiply it by each component in v. 5 times negative 1 is negative 5, and 5 times 6 is 30. So these are the vectors 3u and 5v, and now we can add them. Let me leave that there and rewrite it. 3u plus 5v is the sum of these two vectors. So add the first components, 6 plus negative 5 is 1, and add the second components, negative 9 plus 30 is 21. So there's 3u plus 5v. So that's vector addition, subtraction, and this one is called a linear combination. When you mix, they're all linear combinations, but in general, a linear combination is a mixture of a scalar multiple and an addition, a linear combination. So this is a linear combination of the vectors u and v. These are all linear combinations of u and v.